Well, Light Reading commissioned EANTC to conduct a test of a family of virtualized equipment from Nokia, the virtualized service router, the virtualized mobile gateway, the VMG, together with the evolved packet data gateway, the EPG. And we actually ran all of these tests at Nokia's facilities at Mountain View, California, based on vanilla OpenStack hardware, because Nokia said they wanted to prove that the solutions are interoperable and can run on any sort of platform.
This test program with EANTC has been important for our team because it is an independent third-party validation of a new technology that is emerging in the industry and the marketplace by taking realistic network configurations, realistic service configurations, and essentially configuring them and testing them as they were fully deployed systems allows the reader to really understand how far along this technology is from the Nokia virtual service router.
So under the hood, the key difference between the VSR and the physical routers is our fast path implementation. In the virtualized service router, we've rewritten from the ground up our forwarding plane to take advantage of generalized compute. And we've squeezed the maximum performance we can out of that generalized compute architecture. We call that the FP, the virtualized forwarding plane, and that's really the key difference.
In the first place, of course, testing a virtual router is much like testing a physical router, right? So all of the test methodology is based on RC2544 and other similar standards that are more than 15 years old. But these have to be adjusted to the virtual world in some ways. Sometimes they can be evolved, sometimes they have to be adjusted.
In terms of performance and scale, we have a number of key differentiators in the VSR. First of all, we have a full support for symmetric multiprocessing, which is a processing technique of taking a workload, whether it's a control plane workload or a data plane workload, and distributing it so that it runs in parallel across multiple CPU cores, whether those are virtual cores or physical cores. And that's a key reason for our excellent performance in the virtual forwarding plane.
For the VSR testing, there are four main highlights. The first one is that the solution managed to get 58 million packets per second throughput on a single Intel Xeon E5-2699 CPU with 18 cores. That was a very impressive throughput per core. The second thing is that we reached 80 gigabits line rate throughput on the same system with any packet size beyond 256 bytes. Third, we actually tested the virtual route reflector implementation with 1,000 peers and millions of unique routes to really impressive convergence times. And finally, we also covered denial of service attacks, where the VSR demonstrated that it can protect itself from up to 9 gigabits of ICMP attacks, still letting 40 gigabits of tenant data throughput successfully through the system.
EANTC's test results for our virtualized mobile gateway has demonstrated that it's now ready to deploy in commercial networks. It was tested with a realistic traffic mix of evolving services going forward that had a combination of Internet of Things, machine-to-machine traffic, along with consumer services.
We actually configured a mixed Internet of Things and consumer subscriber scenario with 18 million IoT subscribers and 2 million consumer subscribers emulated. And we checked the attach rates of up to 8,000 sessions per second. We checked that all of the subscribers would be supported with sufficient data throughput, and we also checked high availability and other operational aspects.
And having that combination deployable and manageable really allows mobile network operators to start the deployment of a virtualized mobile gateway to enable new services going forward.
Well, the results clearly show that Nokia's virtualized solutions, the virtualized service router, the virtualized mobile gateway, and the associated functions are clearly there and ready for deployment at larger scale in operators. And we looked not only at one metric, we looked at multiple metrics: the performance and scalability, the functionality and lifecycle management, the high availability, the manageability and coexistence with physical network functions. And we can confirm that these Nokia solutions are scaling and ready for deployment at each of these metrics, and that's what I think we